Hello.
My name is Major Merger.
I am Astrobit, also known as Brian Mulligan.
Oh, I also have a real name too, but my real name is Sinclaire. Hi. Yeah, we're here to give you some top news stories of the month.
All right. So first up, on May 22nd, the first full budget proposal from the Trump administration was released.
Correct reaction, everybody.
Yes. So this is the first official budget that was released by the White House that's intended for the 2018 fiscal year. It includes $19.1 billion for NASA, which is a $100 million decrease from the 2017 budget, and $6.7 billion for NSF, which is an $800 million decrease, or 10%. Was that? Oh.
I told you I clicked it.
Okay, sorry. NASA and NSF, the two funding agencies that are getting cut, or some cuts, are the largest fraction of research funding for astronomy and astrophysics. So pretty much every astronomer here has been funded in some way between those two agencies at some time. The only other major agency in the U.S. that funds astronomy and astrophysics is the Department of Energy. They're also facing a 17% cut to their science funding. So this budget has already been the subject of a lot of criticism. All the major professional science organizations have come out against it. Members of Congress have also come out against it. And Senator John Cornyn of Texas has noted that president's budgets typically are dead on arrival at Congress and expects this one to be exactly the same. We hope. So the next phase, this budget is now being considered by the House and Senate budget committees, and will be under consideration for the next several months.
All right. So, on June 3rd, SpaceX's Falcon 9 rocket successfully launched its Dragon cargo ship for the company's 11th commercial resupply services mission to the International Space Station. So, yeah, nice. So in some ways it may sound pretty standard because it's their 11th mission, but what made this one really cool was that it marked the first reflight of a Dragon spacecraft. So this spacecraft had already flown, well, oh yeah, so it had already flown during the 4th resupply mission back in September of 2014, splashed down in the Pacific Ocean, was then retrieved and refurbished and then used again. So, it's been used this time to supply astronauts on the ISS with nearly 6,000 pounds of supplies and science experiments. Astronauts Peggy Whitson and Jack Fisher operated the ISS's robotic arm to seize the spacecraft at 9:51 a.m. Eastern Time on June 5th, so this morning. So along with food and water, the capsule contains research equipment and even some live cargo, including 40 mice and thousands of fruit flies.
I hope they don't get out.
Yes. I mean, I already knew I didn't want to be an astronaut, but like if you told me I did all that work to become an astronaut, then to get shipped mice and fruit flies, like, I don't know, I spent 4 years in a college dorm. I don't need to see those again. All right, but so it's actually kind of cool, though, because the mice will be used to test a new drug for osteoporosis, and the fruit flies will be used to study the side effects of spaceflight on the cardiovascular system. Do not ask me how that works. So the SpaceX Dragon will stay on the station for about a month before it is scheduled to splash down once again in the Pacific Ocean for retrieval. Sorry, I'm tripping you.
All right. So the Cassini spacecraft has begun the last months in its mission. This is a little bit of an old story, but we didn't cover it back at the time, so we're covering it now. In January, it took its first plunge between the rings of Saturn and the planet itself, capturing images with unprecedented resolution, one of which you see in the upper right corner. This is something that they call a propeller. So in the middle there is a small moonlet. It's only a few kilometers across, the moonlet itself. So you can't see it in this image, but it causes gaps within the rings through the gravity of the moon. Cassini's currently on the 6th orbit of 22. of its 22 so-called grand finale orbits. It's going to continue its mission until September 15th, when it will be intentionally driven into the planet Saturn itself. This is to prevent any possible contamination of Titan or the other moons of Saturn by any bacteria or other organisms that have managed to hitchhike and survive the last, 5 years in space around Saturn. 13 years.
All right, so despite the proposed budget cuts, NASA is still launching some new missions, and it's gearing up to launch the Parker Solar Probe in the summer of 2018. So the spacecraft will be the first to touch, quote unquote, touch the sun, as it will travel directly into the sun's atmosphere about 4 million miles from the star's surface. And remember, we're like 93 million miles from, star. Okay. So initially called the Solar Probe Plus spacecraft, it was recently renamed in honor of astrophysicist Eugene Parker, seen here. And in the 1950s, Parker proposed several concepts of how stars give off energy and first theorized the existence of solar winds. So his work was instrumental in our understanding of heliophysics and how stars interact with the planets that orbit them. So the probe is set to shed light on some of the remaining mysteries of solar physics, including why the sun's corona, or its outer atmosphere, is so much hotter than its surface. And this marks the first spacecraft to be renamed prior to launch, and also named after a living individual. So good job, Eugene. Parker, if you're interested, continues his work as an emeritus professor at the University of Chicago.
All right, this is breaking news. An unusual and extremely hot planet has been discovered by a team led by Scott Gowdy of Ohio State University. It was just announced this morning at the American Astronomical Society meeting here in Austin. According to Marshall Johnson, also known as Captain Exoplanet, who is standing in the back corner there, he was a co-author on the study, and he was also a fellow grad student at UT, graduated last year. The planet called Celt 9b, KELT 9b, is about 3 times the mass of Jupiter and orbits its parent star every 1.4 days. The star itself has a temperature of 10,000 degrees, so this is roughly twice as hot as our sun. Because the planet's so close to the star, the day side of the planet has a temperature of about 4,600 degrees. This is hotter than some stars. And it's so hot that no molecules can exist in the atmosphere of the planet on the day side. So only atomic gas on the day side. So no oxygen, no molecular hydrogen, anything like that. The planet experiences UV radiation 700 times as intense as any other known planet. Because of this, the atmosphere should be boiling off into space very quickly. The planet's orbit is also unusual. You can kind of see in this animation here that the star seems to be rotating this way, and the planet is orbiting this way. We've never seen this in a planet before. This is actually extremely unusual. So it's going completely opposite to the star's rotation. Every other, or pretty much every other system we've seen, the planets go around the same way that the star is rotating. This is due to the way that the planets form. The orbit should be slowly changing its orientation relative to Earth. So here in this picture, you see that the planet passes in front of the star once per orbit. That's going to be changing over time. And so this particular star, the way that it works, in about 150 years, it will no longer be passing in front of the star from the point of view of Earth, which means we wouldn't be able to have discovered or see this planet. So we're extremely lucky to have managed to catch this planet when we did. The other note, this star, Celt 9, is the brightest star known to host a planet, a transiting planet. It's a magnitude 8 for the amateur astronomers and professional astronomers in the room. So it'll make it very, very good for follow-up observations.
All right, so LIGO, or the Laser Interferometer Gravitational Wave Observatory, has done it again. So for the third time in 18 months, it has observed gravitational wave caused by the collision of two black holes, which is pictured on the left in an artist's rendition. So at around 2 a.m. on January 4th, and I know this sounds like old news, but it takes a while, before you come out and, say these sorts of things. But yeah, on January 4th, LIGO's interferometer in Hanford, Washington, which is the lower interferometer, detected a signal, and then 3 milliseconds later, the interferometer in Livingston, Louisiana, located up top, detected the same signal. So researchers have determined the black holes were around 3 billion light years away from the Earth when they collided, and they were about 19 and 32 times the mass of the Sun. So to detect these events, these interferometers have to be super sensitive, like insanely sensitive. So the wave that caused the last gravitational wave they detected caused the space-time occupied by these long 4-kilometer arms. The space-time around those arms stretched and shrunk by 1 times 10 to the minus 18 meters, which is 1,000 times smaller than the size of a proton. So, I mean, it's pretty insane. So, even with the crazy small detection, researchers are 99.997% certain that the signal was generated by a merger of 2 black holes. And so the next big step for LIGO is better constraining where in the sky these events are occurring. So to do that, they have another interferometer called Virgo, which is located in Europe, that will be coming online in the next year. And with 3 interferometers detecting these signals, you can better localize where the source of the wave is coming from, similarly to how if you have like 3 cell phone towers, you can determine a general area of where your phone is.
So if you were here last month, you were here for the first edition. Now it's time for the second edition of what we call Astronomy Not In The News. This is a story that's been covered, that's generating a lot of discussion within the astronomical community. This is based on a website that's called voxcharta.org. This is a conglomeration website of a lot of astronomical papers, so I don't recommend it for the faint of heart. But this month's story is Carina Caputi of the Kapitein Astronomical Institute in the Netherlands led a study looking at nearly 6,000 galaxies that are 11 billion light years away, also meaning that this is how galaxies appeared about 2.5 billion years after the Big Bang. Their study was looking at how quickly galaxies formed stars in this era. This image on the right here is one of the particular images that they took or were looking at. Basically, every spot you see in this image is a galaxy, and the circled ones are a particular set that they found were a little bit denser than usual. But they're looking at all these individual little spots and determining how quickly stars form in them. The results largely confirmed the rate of star formation from previous studies, but unexpectedly discovered that some of the particularly unusually bright galaxies within the sample fell into 2 separate categories. So they either form stars closer to 10,000 stars per year or closer to 10 stars per year. The fact that there's 2 separate groups was unexpected. It was expected to just kind of be a continuum. There's some that are forming a few, and then there's some that are forming a few more, and some that are forming a few more. And I discovered, no, it's actually 2 completely separate groups, which means galaxies in the early universe probably work in one of 2 ways. Either there's gas slowly being added to these galaxies that turns into the stars, or they go through massive bursts where kind of the star formation gets ramped up and kicked into high gear, probably through a process of something like galaxies merging together or coming really close to each other and disrupting one another. So this is going to require much further follow-up in order to understand exactly what's happening and really come to terms with why. So that's all we have for Astronomy in the News for what are we in? June 2017. Barely June.
But before we go, it's Astrobit's birthday today. Everyone say happy birthday to him.